about like um, what is eco design for sustainable products and regulation. And I think and I hope for you, this means that is this tool is not only nice to have, but I think the idea of this is to give you like, a core engineering like tool that you could use in the future. So what I try to show in this seminar, it was not something so abstract, and that's what I try to do. So that's why I kind of try to do it in a different way. And so through like the practice method that we use, and I know it was not easy, we kind of identify the hotspots of this technique for creating the life cycle assessment. So I think the students did a great job. I know it was like a really short period of time for doing all what we did, and I know some of you felt a little bit overwhelmed with with all the things we did. But what is important for me is that, as I told some of you, that you can at least now have like a discussion with your colleagues of what life cycle assessment is, right? So I hope LCA will help you make informed decisions in the future, and I hope you get to use this method maybe during your studies or maybe in the future while you will be working somewhere. That's what happened to me, right? I have to learn how to do this, how you did it. Of course, like, the time frame probably was different, but yeah, I just wanted to again thank you all, and yeah, I'm really glad I had the chance to spend some time with you guys. So yeah, maybe you can now do the presentations, and then it will be great to have your questions and your feedback later. It will be amazing. And yeah.
Yeah. So we start with the first presentation.
Okay. Hi everyone. Thank you so much for coming today for our presentation of our completed LCA. I'm Hassan, and my teammate is Florine from Skopje, and we will be presenting about the life cycle assessment of e-scooter. Next, please.
Hi everyone, my name is Florine, and like Hassan mentioned, our project is the life cycle assessment of an e-scooter. The goal is to quantify the environmental impact of a shared urban e-scooter to identify the life cycle hotspots with a comparison of different scenarios. The scope is the analysis of the e-scooter from raw material extraction to the manufacturing use and the 3 different end-of-life maintenance scenarios. The functional unit is the provision of 1 passenger per kilometer of urban e-scooter transport. Next slide. Yeah, for the bill of material, we have shared our material in 6 different component level for the LCA model. And as you can see, the total bill for the material is 15.5 kg. So we have the powertrain, the plastic part, battery part, BMS system, and the frame. Yeah, thank you.
Okay, so as you guys have seen the bill of material just now, maybe you can go back for 1 second. The majority of the e-scooter itself, the components, the majority is the aluminum, which plays a large part in the carbon footprint of the end result, and also as well as the battery pack. Next, please. So for a bit of context, we will share with you the life cycle flow of how what will happen to this e-scooter from when it's manufactured up until the user uses it and into the end of life. So it's divided into 4 parts. The first part is where we manufacture the e-scooter, which includes the extraction of the raw materials and the transport of the materials, as well as creating the parts and then assembling it into one final complete e-scooter. And afterwards, it will be distributed to the consumer. And that is when we go to the next stage, which is the user phase. And in our case study, we decided to go for 3 different types of scenarios, which is scenario 1 is a linear economy, meaning that from the usage up until the end of life is just a single use. So no change of tires, batteries, or no maintenance. The second scenario is a reuse economy, whereby we decided to use the scooter up to 10,000 kilometers. So that's 4 times, sorry, 4 times the normal usage. And the last scenario is a recycled economy, whereby it's the same as scenario 1, 2,500 kilometers. However, in the end of life, we decide to recycle some parts of the components as credits. And that's when we go to the next stage, stage C, is the disposal. And for each scenario, there's the different end process. So for scenario 1 and 2, it will go to the final waste. And scenario 3, we have an additional recycling material for the credits, for the carbon footprints. Next, please. So after we've done our LCA, we've calculated, this is our result. For scenario 1, as you can see, we have the highest impact per person per kilometer. And this is because of the large carbon footprint that is caused from the raw materials and also the process of creating the batteries, such as the lithium, the cobalt, and as well as the aluminum, which consists of the majority part of the e-scooter. The second scenario, we can see that it has the highest lifetime impact per person per kilometer. And this is because we extended the usage of the e-scooter up to 4 times, and therefore we add an additional battery for times 4. However, you can see, because we extended the life of the e-scooter, if you divide it by the per kilometer per person, it is actually 60% cleaner than the first scenario. And for the last scenario, which we decide to recycle, it has the lowest impact per kilometer. And this is because of the credits that is inputted, that's given back into the system when we recycle those rare metal materials. And although it has a higher total lifetime, it is much better than the first scenario because we recycle those materials. So next please. So our conclusion is that in scenario 3 shows the best case in order to reduce the carbon footprint. However, it is the best for manufacturers if they want to create the lowest environmental impact. And for scenario 2, it is best if the goal of the manufacturer is to minimize the environmental impact over a long period of time. So our conclusion is that for the product, especially for the e-scooter, it is best if we maintain and reuse the e-scooter, and therefore it will reduce the carbon footprint. And yeah, that's all from us. Thank you.
I think we can keep the questions for the end, right?
Yeah.
Good afternoon to my fellow professors, my colleagues, new colleagues, my classmates, and to all the audience that is here today. So just heads up. I am working with Elvin, and currently our LCA is still in progress. So the results will be presented later on. So in this presentation, it is more to sharing our experience and the feedback, and maybe also I will share my opinion on why this subject or this LCA course is important for us. Okay, next. So I will share. I just give a brief overview to what we are working on, and I will share my experience with Elvin working with LCA and our feedback. Next. So LCA, from what I understand, is a scientific method we use to evaluate the environmental impacts of a product's process or service throughout its entire life. That means from material acquisition to the production, transportation, and to the consumer use, and also to the end of the life. So for me and Elvin, we choose RTX 5070, the GPU. We want to compare whether this more advanced model against the 4070, whether the efficiency gains offset the manufacturing loss. And also we want to measure the functional unit. The comparison we want to make is to run this GPU on the ultra high settings, which is 1450p pixels over 7300 hours, which also equivalent to 4 hours per day for 5 years. And this analysis is from the cradle to grave, meaning from the raw material acquisition to the end of life. Okay, so this is some experience that me and Elvin gained from doing this LCA. So the first one is the life cycle inventory, where we collect data. So this includes the raw materials, the production, which means the energy use during production, transportation, including the fuel, also the carbon emission, and also consumer use. And then the source, some of them we collect from EPDs, which can be obtained from public sources and research papers, and also some, if we are lucky enough to get a manufacturer's EPDs, but most of the time it's discrete or we need to pay to get the data. And also for some data that we cannot get, we need to make assumptions. And for this, we use the help of generative AI. And we mainly use the Excel to construct and structure our data collection. And then after we done this LCI, lifecycle inventory, we do the modeling of the open LCA. So we convert this data to models, and then open LCA will do the calculation. And within open LCA, we can, some of the analysis tools provided model graph and Sankey diagram. And I think this is important to help us to see how these materials that produce this product, in our case is GPU, and we can see where these materials can impact or influence the environment. And part of the impact analysis includes climate change, land use, and water use. Next. So this is my final slides. I will just want to conclude that I personally think that LCA is important, especially for assessing the environmental impact of a product, especially if we want to create our own product, or we are going to be a big manufacturer. It's important to know where our product impacts the environment. And some of the lesson learned is, if we want to perform a quite correct and well-designed LCA, we need to have a clear understanding of the product, and we have to acquire the accurate data. But in our case, since it's just a simulation or assignment of LCA, we have to make a lot of assumption, which makes the data less accurate. And then the last one is LCA is flexible, and every product have their own unique LCA, which means that even though, for example, we make a assessment of same product, RTX 5070 and 5070, but when we define the different functional unit, it will have a different analysis. And that's all from me. Thank you.
Okay, hello everyone. So I will present the first part of our LCA project. We decided to work on the Bosch Pro Pruner because we had another class about this and it was focused on the 3D modeling. And we thought it would be good to have both the 3D model and an open LCA project. So in this first slide, we can see the product overview. And here what's important is that we have to specify our target user and how many, like the scope of our study. So in the next slide, so in the next slide, we can see the goal and the scope. So we first started with the entire system, and then in the middle of the way, we saw that it was very complicated to do something like this, and we reduced it to only comparing the batteries. So the current battery used is the lithium-ion battery, and we wanted to compare it with the lithium iron phosphate, which is an alternative that is now commonly known to be much better in terms of performance and also environmental impact. And we wanted to verify this with the Open LCA. And our functional unit was to be able to provide 1 million cuts in the scope of 5 years. And just like the other groups, we do a cradle to grave LCA. And I'll let Hamza present the results that we found.
Hello, everyone. Yes, for this comparative study between the two batteries, we have encountered many findings. Among them, and the most important thing that we find out is that LFP battery has a significantly lower environmental impact than the lithium-ion battery, especially in the categories of global warming, potential acidification, and mineral resource. And as Iman said, this is known in literature, and we just verified this known scientific result. Yes, please. Next. And as a conclusion for this project, after doing all the model and the diagrams in Open LCA software, we can say that LFP battery is the environmentally preferable choice under the studied conditions in the manufacturing in Bosch in Germany, and with the European and especially the German electricity mix. And the difference between the two batteries mainly resides in the manufacturing phase, as it's known in literature and verified in Open LCA Sankey diagrams, where the LFP avoids the high impact extraction and refining of cobalt and nickel that are not present in the that are present in the lithium-ion battery. And yeah, that's it. And thank you for your attention.
Thanks.
Okay, hello everybody. I'm David. It's our teammate Agahan. We decided to make an LCA about the NVIDIA Jetson Orange Developer Kit. So it's a small PCB for providing computational edge, AI edge computational power. And next slide, please. We will go quickly through the goal and scope, implementation and our inventory. And then our Open LCA, the Open LCA model. And last of all, Again, we mentioned the limitations of our LCA and we face while doing the LCA. Next page, yeah. Okay. So goal of the study is to find out the environmental impact of, in our case, one
and NVIDIA Jetson Orin Developer Kit as a PCB. The functional unit, it's there to provide this computational power over 5 years in a developing context. So it's not a product which runs day and night. So we calculate with 15 watts, 5 years, and half a day of running time. Key specifications, it can run between 0 to 35 degrees Celsius, has a maximum output of 15 watts, and weighs about 175 grams. Next, please. Yeah, next. Yeah, you can see our a small visualization. The boundaries, so we excluded packaging from the LCA. So we start on the left side with the inputs, then the phases A1 to C4, and then on the right side we can see the outputs. So, and we use the LCA database Extreme Open LCA to model a model. Next.
Yeah. Now after we covered all these functional units of our component, we have here final results. We can see. So and yeah, main takeaway of these results again is that yes, our total impact of our product is 385.09 kilogram of carbon dioxide equivalent, and of course it's really important to identify that use phase is accounts for almost for 99% of total impact emission, and yes. Of course, manufacturing phase is yes 1.1% of total emission. And yes, here in the on this picture we can see this main in component phase. What accounts for total impact, which are electricity, container glass, and aluminum extrusion profile, and fibers and landfill of metal, which is part of C module, end of life module. Additionally, we have considered this D module. D module is recycling recovery, and where we can, and then we have in the conclusion we can say this: what components are the most carbon intensive? These are carrier board and system on chip and memory components, and aluminum, followed by aluminum heat sink. So yeah, these are our results. Okay. Yes, these are this in the same way. This container glass, aluminum extrusion in divided. So yeah, these are our main findings. Thank you. Thank you for your attention.
Hello everybody, this is our LCA about our self-developed motor controllers. We developed it last semester, and this is our 3D motor controller. Here you can see a diagram, and what I want to mention is our goal was to concentrate a motor controller which leads from the hydrogen cell to the motor, and the function unit was to still have a very high efficiency of 95%. And you can as well see our cradle to grave part where we started with the several components, where we had several raw materials. We considered them until the process of manufacturing. From there, we transported the several parts to our assembly, where we assembled the motor controller, and then we continued with the use phase of the motor controller. We considered the motor controller for 100 hours, and at the end we have an end of life. Here's just a small overview of our components, and we had a total mass of 36 grams.
So just before going okay. Yeah, so before going to the open LCA, we first had to have well-defined the diagram that Rafa previously mentioned. So as you can see here, this is a representation of all the stages or the phases of our life cycle assessment, in this case of the motor controller. So within each phase, it contains like different flows or processes. It was struggling. We were struggling at the beginning, to be honest, with this. But yeah, at the end, we got used to the software, and we understood how important it is to specify within each phase. So everything, I mean the content. So yeah, that's pretty important. The next one, please. These were our results, and this is the Sankey diagram. You might be wondering, what are those red lines? We've had the same question too. But then we found out that this is like creation of energy, let's say. And the red lines represent the red lines represent the CO2 emission or the waste energy. So the bigger the line, the most waste it has. So these red lines that we get, it's because how we defined the previous stage. So as mentioned, and also as my colleagues previously mentioned, we had to improvise, let's say, because we didn't have all the elements within this software. The database we used was free, so it was not that well structured, let's say. So we work with what we have, and at the end, although we had these results, or we're not that precise, we learned that it is important to define each stage or phase as accurate as possible. So
very interesting, the Sankey diagrams, for example, that in the use phase we have the highest emission, even though we have a very high efficiency of 95% for the motor controller.
Yeah, and well, as conclusion, we had some database errors, but we had also, as Rafa mentioned, a high energy demand in the manufacturing process at the end of the life cycle assessment, and the dominant part was the use phase of the motor controller, and yeah, it's at the end. We are thankful for having this lecture, because we understood the importance of having a life cycle assessment whenever we want to create or product or produce a product. So I think, yeah, that's what we learned, and it's very important. So if you have further questions or anything, you can ask. Yeah.
Thank you. Thank you very much.
Okay, good afternoon, everyone. My name is Diego. I work with Luis, but he's currently working on his part-time job, so he's in his favorites. Okay, next slide, please. We decided to work on a 3D printer because last year we make an exercise to bring into life some 3D printers, and currently we are also working in some different projects regarding to 3D printing. And we would like to know how much is the impact these 3D printers can bring to footprint, carbon usage, and also the energy that every 3D print use nowadays is also really important for the additive manufacturing. And it's the most common manufacturing that students use. Also, it's more accessible for everyone. So let's check into the product in the functional units. After that, the LCA diagram, which is going to show all the stages that we are going to go into. And finally, the results and conclusions. The product, we select a 3D clay printer. Currently, we are working also to make some bricks in clay, which are going to be used for cooling interior spaces. Clay has a property that his porosity can evaporate water that is coming from the rain. And also the air that is coming through this clay and these pores can evaporate the water and cool the interior spaces. So for that reason, we start to evaluate the environmental impact of the 3D clay printer. Firstly, we disassemble this 3D clay printer in these 5 components, these 5 subsystems. And in the following slides, we're going to go deep in the details of which materials are used for making these subsystems. Next slide, please. The functional unit is the brick that we designed for the cooling, passive cooling effects. In our estimations, we calculate that the production of 1,000 of these clay bricks over 2-year lifespan of the printer, and well, all the details of this prototype that we're going to print this semester. Also, how much time we need for every 3D printer to make every of these 3D clay bricks. Next slide, please. Well, now getting deep into the LCA diagram, we start to retrieve information about the raw material acquisition, the mining, and the extraction of ore. The most important materials here were steel, aluminum, copper ore, crude oil, and oxides that is also used to make the aluminum. After that, the material processing and refining, and we check some refining process like electro refining, polymerization, also vulcanization to make rubber, manufacturing and assembly. In this case, the 3D printer, we check a guide where all the mostly important systems of the 3D printer are already recycled or reused, like we did the last episode. And in this manufacturing and assembly, we just show how the process like machining and assembly, how much energy they need to make this 3D printer. After that, we have the use phase, how much electricity consumption the 3D printer have.
to produce every brick. And finally, how can we recycle, reuse, or waste our 3D printer? As a result, we got a Sankey diagram. As our friend Alberto, he explained what is about these red lines, which show that the most CO2 consuming process are the transportation, because most of the subsystems are already recycled or reused, and also the manufacturing process that are made in each step is not wasting a lot of CO2 footprint. And in the next slide, we can see that the most consuming CO2 process is the transportation of all of these raw materials and refining materials. Most of these rare materials come from China, and that's why the shipping process in containers brings a lot of CO2 in our EDP, that is the process that we are making to evaluate the whole CO2 footprint of the 3D printer. Finally, we have in the end of life of our 3D printer, which subsystems can be recycled, and what is the percentage that it can be recycled, reused, or waste. In this case, the most common or the most easiest elements that can be easily reused or recycled is the aluminum profiles, also the steel in the clay tank. And the most difficult subsystems to reuse or recycle is the Arduino and electronic parts. And well, as a conclusion, we also noticed that the most important process in here and the results that we show is, for example, the transportation of the materials. If we have the opportunity to reuse or to make a local agreement to bring the components easily, they are going to reduce the footprint in most of the 0.5% of the total CO2 footprint in the 3D printer. Yep, that's it for my presentation. Thank you so much for your attention.
That's it, right? Yeah. So, thank you for all the presentations. I don't know if there are any open questions you'd like to ask.
I mean, before we move into questions, like, it's really important, and I make an emphasis when doing this exercise with the students. It's hard to say that these are like results, right? Like, this was an exercise to see how the method of life cycle assessment works, and to get in touch with the tools that we're using to actually get there, right? So I guess through your presentations, you saw a lot about your goals and your scopes, and your boundary conditions about the processes. And it's worth mentioning that we didn't have like theoretical lectures in this seminar. I wanted you to kind of do things to actually learn some of those concepts through this exercise. And by no means, I'm not saying that what you're showing are not accurate results, but like, they're just like the result of what you were learning during these 5 weeks. Okay, so yeah, if you have some questions, and then if you're not if you're not sure what to ask, then I think the main idea of this exercise was for you to understand what LCA is, right? Like right now, and we had this discussion several times, we spoke about regulations and what is coming for us as engineers and what is our responsibility. But yeah, somebody has a question about like what we presented. I know that all of you have different projects. We tried to choose something that it was related to what you're working on right now. But yeah, I would love to hear your feedback from this exercise and your thoughts as well.
Well, for me, this presentation excited my curiosity. So it's not meaning to deep questions, but I would be indeed interested. So it was perfect for me. Thanks a lot. So I have a lot of questions. I will try to focus.
Some students have lectured at 2.
I have also. Cradle to grave, cradle to gate. It's the opponent. All that does cradle to cradle include inside of that. So if I make a cradle to cradle, I'm going through the total recycling and then re-putting inside the material I recycled. How does that fit into this kind of analysis? So it's really my interest. I'm not trying to touch you. I just don't know.
That's a difficult question. And we have not gone that far, but Nico, do you have any answers on that?
I'm fine. You're muted.
Yeah, I couldn't hear really well the question, but I just heard a little bit about like I think it's not clear the end of life and how it's reused, the materials, how they are reused. Ole, can you like try to reframe the question or?
Yeah, if I think about a cradle to cradle, then I reuse everything. Where is this? Yeah. Where do I stop? If I say cradle to grave, then I'm going from beginning of the material.
Good.
And if I want to close the loop, how do I do that?
Yeah, okay. Like that's a really good question. Like I decided to put the students to go through the raw material extraction all the way to the end of life exercise in order to go through the whole process of the product. Most companies, what they do is they do gate to gate life cycle assessment, right? And they sometimes they don't care about the use phase or they don't care about the end of life, right? So the idea of the exercise was to understand the whole life cycle of the product, right? And now your question about like where it ends, that's a good question. I think I put a very nice diagram in one of the sessions I had, and it's like this image about the linear economy and how the circular economy works, right? So when you go to the circular economy, there is a lot of energy you have to use to actually reuse things. And so when you say like where does it end, then it depends. It's a complicated answer, but for example, there are some materials that like are easily reused, right? So and sometimes they are cheap to reuse, but there are others that sometimes it's more energy costly to reuse or to put back into the production line than to throw them away, and so like maybe plastic is one example of that. You can reuse plastic, but in more cycles you will lose the qualities and the mechanical properties of it. Therefore, like if you want a really good product made out of plastic, you rather use like pure or virgin plastic, or you try to mix it, right? So this method actually just shows you how you can understand those type of questions. So yeah, I think that's why it's very important
to fix the limits.
Yes. Yeah, no, to use this as engineers, right? Like we are used to design products that work, or they're technically great, but then we never think about what happens to them after they die. And a really good example that we saw last week is that the European Union is putting back the idea of having mobile phones that have reusable batteries, right? Or like exchangeable batteries even. So that's a great example.
Yes.
Yeah.
I think you have to stop me. First, there was recycling and reuse. There was two possibilities. Could I combine those?
Yes, you can combine.
So I would be even better.
Yeah, but you have to do the analysis for that.
The focus on CO2, is it because it's the most common thing, or because you have looked at the different parameters of ecological footprint and have decided that this is more important than another one?
Actually, for our lecture this time, we decided to focus on the carbon footprint. And you can actually in the program you can also focus on acidification or the ecological impact and so on.
Okay.
Yeah.
Have you thought about how to compare these different parameters, how to put them together in any way? Because if you have water use and you have CO2 emission, how do you put them in relation one to the other?
Yeah, so the analysis that we did actually is to see which scenario is the best case scenario for reducing the carbon footprint, and it's to make us aware as engineers in order to choose which case in order to design our product for the best case scenario of the least carbon.
Because I believe at least Europe is having some numbers where you can put these different parameters in comparison. So making a mix out of this, if I really like.
Yeah, Ole, maybe to add on that, there's a framework for the European Union, and there is some regulation that it's asking for manufacturers to actually show what is the a global global warming coefficient, they call it, right? And so through the software you can actually calculate this global warming coefficient, which is the result of one of these LCAs. But as I mentioned, you can also calculate only the carbon footprint output of some specific part of your process, of in this case of the whole life cycle of the product itself. So that's why it's so important, and we spoke very little about inventories, like inventories and the collection of data. And this is the part where the students, I think, struggle the most, where like when they were like actually acquiring the data, because it's it's so hard. And we have like Veronica that she gave us a really good example of how they calculate the carbon footprint of cardboard boxes in Spain, and then she was saying like the data that they acquire is from the people they buy the products from, right? So they ask for the results out of their LCAs. So I think the data acquisition is something like super important that I think the students also like got in touch with through this exercise.
Say something. That's a strong conclusion, actually.
Yes, please. Go ahead.
So I would just like to say that although this is not really in-depth study of our LCA.
If you come to front, so they see you better. Can you hear me now?
Yeah, I can hear what Hassan is saying. Yeah.
Okay, great. So what I'm going to say is that I felt like this program itself was very it sparked my curiosity as well, as Heseka said. And I felt like not only as an engineer that we think of how to make a product, but we also have to think of the environmental impact. And with this course, it allows us to think more carefully on how we make our products. So as we graduate as engineers one day, we would be more aware and more tentative on how we choose the materials and the process of everything. And I felt like this program was very interesting because growing up as when learning as an engineer, we only think of how to make things, how to calculate stuff, but we never think of the environmental impact as well. I hope that not just for this year, but in the future as well, we will have this course, and maybe Nico can go as well as an in-depth teaching on this course, but not only for the EU4M students and also the INGENIUM participants, but as well for the other students as well, and maybe not just for the engineering department, maybe for other departments as well. And so yeah, thank you so much.
So I think this was a great confusion. I don't have to do any job, right? So I'm going to also say, it was a pleasure to work with you. Nico did a great job, and I hope this lecture will be a prototype for future lectures in our EU4M engineering network. And
it will be our pleasure to go on with this. Thank you all.
Thank you everyone for coming and for joining. Yeah, this is more like talk. I don't know if Mike wanted to say something. I don't know. I see his frustration face there. Like, I don't know. Maybe we can give the speaker to like Mike.
No, I think this course is very interesting. I got lots of questions because I'm completely out of this scenario. And when I hear the students saying that it would be very interesting to have this course, I completely agree. But then I think of real life, and unless something comes from the European Union or someone forcing companies to take this into account, I think unfortunately money is the only thing that's just going to count. And these programs must be reinforced by European politic policies, I think. And I hope they will. But at the moment, I like the initiative of Nico and people like him trying to push these things in, making us aware of this big problem. And I only hope this simply keeps growing. The program is the micro-credential has been very interesting. And as this student said, it would be very nice to have it included in the EU4M or in other degree programs. So thank you, Nico. There's nothing else I can say. Thank you for trying to teach this new generation what they should be aware of. As someone said before in a meeting I had a few weeks ago, I hope these people will do it better than us and make the world a better place. So this is a step forward in that direction. So thank you. I had one question for Nico, but not related to the topic. It's more related to the class. You were talking about 5 weeks, a 5-week course, was it? How many hours in total?
Well, it's nice that you asked that question because I was supposed to do a lecture only once a week, but I decided to divide the group into small groups and then just have private lessons with each group, right? So I did not do lectures. So to be honest, I didn't count how many hours I spent with each group. And to be honest, they were like many hours because I scheduled, different times, even some weekends with some of the groups. So, but the truth is that I didn't give any lectures, Mike. So it was more like I was trying to follow up on what their projects were. At the beginning, yes, we had some common lectures. So, and that's the part of, that Alex was mentioning about this new virtual way of like teaching. So, and, I was also a student, and I think like when, there were like these lectures that were like, I don't know, 50 people, and virtually you probably have the attention of 2 or 3 people, and then you lose the attention from the rest. So I think this idea of doing something for learning or learning through doing, right? It kind of works a little bit. And as I mentioned at the beginning, my idea was like just to share some of these little concepts of what life cycle assessment is. And I'm sure that all the students right now, if somebody asks them in an interview or somewhere, if they have worked with like, what is life cycle assessment?
Yeah.
And just to say something about what you said, like, you don't know if this is important. Like the European Union already has some legislation that says that, most products should have like a digital passport, right? And this includes like what an EPD is. We didn't speak about what EPD is, which is like the environmental product declaration. Mm-hmm. And so most products starting from 2030 will require, environmental product declaration. If you actually, and we did this exercise with the students, if you Google, like environmental product declaration of like an electric breaker, for example, like the big manufacturers, they are already doing it. Yeah. So, and so it's happening. And that's why I think we start doing this. I think the initiative came from Annette and from Martin. So I'm actually happy that like they invited me to do this because I did this through my PhD. So it was just a great experience. So again, guys, thank you so much for joining and for your patience. And yeah, thanks a lot again.
No, thank you. From my point of view, at least.
Just to say, it's not true that we are an island and nothing happens outside. Many big companies, Bosch, Saint-Gobain, even Airbus, and so on, are using this kind of tools. the idea that there is a total backlash and nothing happens and the government should do something is a misunderstanding of the situation. Please, we have to push from down so that from up their push functions also. That's a really psychological important. Sorry.
Point for Mike is you were asking for the number of hours because we planned the lecture for 2 credits, which means 2 hours per week. And I helped to organize the group a little bit. So Nico had a lot of lectures and the students told me, I thought it will be an easygoing course with not so much work. And at the end, they scheduled private time with Nico every week for 20 minutes, but very often it ended up in 1 hour. And Nico sometimes told me, I will come to an end, but really I am taking it's taking a lot of time. So I think, sorry, Nico, we took you like for 2 credits at the end. Thank you very much that you went through, and thank you very much to the students that put a lot of effort. And that you did it. You came to an end and did not throw it away.
Yeah, as some there are some groups that haven't finished yet, so to be clear. But no, yeah, it's okay. We will have like some other meetings. Yeah, we'll have some other meetings. Yeah. Yeah. Anyways, thank you again, guys. Thank you so much for your time today as well, and for like meeting there. I hope you enjoyed like the rest of the afternoon. And yeah.
Okay. Thank you, Nico. Okay.